We're going to go over, actually we'll go over fire drills. And this requires a little bit of extension on your part. There's some of the questions that we do. There's one that shows up on tonight's homework. I think it's the first one. I think it's number 10 if I remember right. Where it starts talking about like using linear relationships. And I don't know if they're not doing enough extensions with you and really actually enriching you or just giving you, people pleaser points. You have got to be able to look at a situation, analyze what's going on, and see, is this right, is this wrong, does it make sense? And one of them that we had was in 10. This one here was one that a lot of people, or at least some people, came in and had questions on. And again, I love when you have questions because that shows me not only did you do the work, but that you're invested in your own success. You sit there and you go, gosh, I got to this point, I got stuck. So you don't know how to do it, but you want to do better. And we come in for 10, and I had somebody say, well, I don't know how to graph it. Well, how many points do you need in order to give out the equation? To graph a line? How many points is a minimum? 2. Easiest 2 points to plot that are going to give you a full and complete picture of what the graph is doing is the x-intercept and the y-intercept. Well, let's say this. Who can remember how you find the x-intercept? No. I love it. I don't know how you make it through GEO. This is day 1 of GEO. To find the x-intercept, you go through and set the y equal to 0 and solve the equation. So if you don't have it down now, you don't get it by listening to it, you get it by doing it. So if you need to find your x-intercept, you set the y equal to 0 and solve it out. And when I do that, I get 1,000. Then I go over and say, how do I find my y-intercept? We set the x equal to 0 and solve for y. And we get these two values. And I got 2 points. I know my y-intercept from the algebra ends up being 360. The x-intercept ends up being 1,000. I go through and literally plot those two, sketch it out, and then go forward. And then the B question says, well, what do these mean? What do the intercepts represent in context to the situation? So I know what the x-intercept value is. I'm asking you, what does it mean? Well, the equation that you're given represents, what is it, the number of hats and sweatshirts or something that they sold? Is that right? Yeah. So in this case, when I'm looking at the point 0,360, that means if they sell 0 caps, they need to sell 360 sweatshirts in order to meet that amount. And the x-intercept says if they sell 0 of the sweatshirts, they need to sell 1,000 of the caps in order for it to make sense. So that's putting it in context. Now the other piece was this, and somebody said, well, your graph is wrong. They go, you didn't go through and extend the graph out. I don't need to extend the graph out because, again, this just shows, and I'm not mad at you in the least. It lets me know where you're coming from. But you've got to be able to analyze this. Hands up, please, if you can tell me why I wouldn't graph the pieces of this graph that are in quadrants 2 and quadrant 4. Why wouldn't I graph what's in 2 or what's in 4? Put it in context. What's going on? What do you want to say?
You would sell a negative amount or something?
Yeah. In quadrant 1, the x and the y are positive. You can't sell negative hats or negative sweatshirts. You have constraints on the question that are placed by reality. The other one that was a struggle were those calendar questions, and I did it with 2 or 3 people this afternoon. And the first thing, if you're struggling, I got to see on there an accurate graph on the Cartesian plane. Now, I know that you all didn't hear Cartesian plane beforehand, just so we're aware. Somebody goes, well, what is it? Does anyone remember what the Cartesian plane is? And we go over it. What is it? Yeah, it's the XY plane. That's how you refer to it. It makes you sound so much smarter. You can look down on the peasants that don't use the correct language. So I go through and graph those out. It gives you the 3 points, and they say, well, I don't know what the answer is. So literally, we sat there, and I am the first to admit, I don't teach geometry because I hate it. There's all of these stupid, there's medians, there's altitudes, there's centroids and midpoints, and all of this garbage. But I don't remember what they are. So I didn't know what it was, and the person was sitting next to me, and I go, what do you go through and do? And there's one like it references a median. So we go through and we type in, what is the median? And we hit enter. And then the first, it comes up with the definition of it, right? And it gives you a couple of different entries. But the first one that they said was it was an apparatus to go through and divide 2 lanes on the highway. Now, do you think that's the definition that I need? Probably not, seeing as we're talking about triangles versus driving on the road. So then I went through and said, well, we're talking about a triangle. So I go, what is the median of a triangle? Came with a beautiful picture, showed me all this stuff. We were able to solve out the question. The next one was, what about the altitude? Well, I thought the altitude on it was the height, but it's not. It's the distance, the perpendicular distance from any one of the vertices to the opposite side. So we went through and found out what that was going to be, and we constructed out the slope from there, made it go through those points. All in all, we finished the assignment together. All of those questions we finished in about 17 minutes, because I started a timer when they came over. That included me Googling half of them, or Googling those 2 calendar questions, because I didn't know what, it didn't have a center. It didn't have like an altitude and a median, were those the 2, if I remember right. So if you don't know them, just look them up. You're fine. But you have to be able to take that step, especially now since the district gives you the whole computer. All right? So it's okay to go through and struggle, but you have to be able to go through and take that little bit of a chance. Does someone over here have a question? No? Okay. So what we're going to ask you to do is, and this is another thing, I tried, if I remember right, I went out of my way. Did we all go through and do it out on separate paper? I think I tried to remember to tell you that about 40 times. Make sure your name is at the top. Hand those up and over now. And have your note packets out. If you need to go through and fix something, fix it. If you got multiple pages, there's always a stapler on my desk. Well, okay, so what we'll have you do, go grab a sheet over on the side. Just get it to me tomorrow morning. First thing. Yes?
I can put a graph calculator on the computer.
Okay.
So
Can you just give me a sketch of it? In the future. You don't have to. In the future, you're fine. The main thing is we have to just get accustomed to how much we need to go through and show. Okay? So, if it involves some visual representation, make sure that you show it. When we talk about there being no math magic, what I'm saying is this. If I looked at your paper right now and saw that answer, and there's no drawing, there's no nothing, it's that. When we talk about math magic, that's what we're talking about. Magically having the answer with nothing to justify it, even if it needs it. Yes?
I wrote mine.
Okay, get it to me tomorrow morning. Just copy it over on separate paper, okay? The reason that we don't want you to do the homework in this, and in the future I probably won't even give you the packet, you just have to go into Google Classroom. By the way, some people also complain that it's small. I know it's small, it's posted in Google Classroom, you can blow it up as large as you would like. Don't do it though in here, because you're going to need to go through and do the next day's homework, and if it's handed in, you won't be able to. Now, we left off, I believe we're on page 7 today, so make sure you bounce over to page 7. So what we're going to be going through and doing today is at page 7 that we left off on your notes.
You had us going up to there.
Okay.
Because we didn't.
What we're going to do, we should be leaving off at or around this topic here. Now, the stuff we're going to do, I'm actually going to talk about something and then go back to what it means, or by what it is from the definition. Or we'll talk about it and apply it, and then we'll write out the definition. You all should have done about a 3-week unit back in Algebra 1 based on functions. And a function is a relation where every input has exactly one, or at most one, output. We're going to talk about what relations are. Relations are not necessarily functions. Relations are just mappings of inputs and outputs together. It's possible to have a relation that's not a function. All it does, it's an input, then an output. Looking at what we've got here, and you need to know that the domain is the inputs and the range is the outputs. So, if you've got that, that's the whole thing we're working on today, in a nutshell. Looking at what we've got, now this is a relation, it's a set of points. The first thing I'm going to ask you to do is identify what the domain on this would be. Now, the domain is the input values. It's not everything, and there's 3 members of the domain in this relation. It's these three inputs. These three outputs then would be your range. So if I'm listing out the domain, it's three number values, so we're going to give a set of fancy brackets. And what we're going to say is, now I ask that you list them out from smallest to largest. So we have three members of the domain. Looking at this, Michael, what would the smallest member of the domain be?
-9.
And then?
1.
And then?
3.
There you go. The next thing I'm going to do then is look at the range, and I'm going to list that out from least to greatest. So I'm going to give the brackets there. And Teresa, what would you say that the smallest member of the range is going to be? And then? And then? Perfect. The next thing, and this was a struggle for me, when I graphed this out, hands up please if you can tell me what shape I get if I graphed out number 2. I love it. The other class, the first period this morning, they just stared. This should not be like a Rubik's Cube for you. What do you want to say? Yeah, it's a linear relationship. Think about what that graph is going to look like. You know exactly what it's going to look like. Here's the x, here's the y. I know that the y-intercept is -5. The slope is 7, so we get from here to here. Now, looking at that, we're going to give out what the domain is and what the range is. The domain is the inputs. In this case, on the Cartesian plane, it's the x's that are going to give you out a y. So I start off and say, for my domain, looking at this, you go side to side to figure out domain, up and down to figure out range. When you go to the left, you don't encounter any jumps or any problems with the graph, which means our domain goes all the way forever to the left, and then as I go over to the right, it continues to go forever. Every member possible is in the domain, which means there's two ways you can list it out. The regions list it out most of the time as being all real numbers. That's the sign that everything works. Sort of fancy or double-sided R. Or you could go through and list it out in interval notation. Everything after this year in the regions accepts interval notation. So when we're doing it, we're going to stay away from inequalities and start working with interval notation. And we'd say, you all did that before in Algebra 1. You remember parentheses means it goes up to but doesn't include that value. A hard bracket means that it does. So it goes all the way out, and it always goes lower bound, comma, upper bound. This goes all the way out to negative infinity. So we'd say the domain is everything going to the left, no gaps, and then it continues going to the right. That means my domain is negative infinity to positive infinity. That's what the interval notation would tell us. You always put parentheses for negative and positive infinity because it's not a number, it's an idea. You can't hold that many apples. Now, the next thing is what our range is going to be. Does anybody want to take a guess as to what our range is going to be, or the y values that we use? We've got one person who can tell us. Remember, it goes lower bound than upper bound. Who wants to say?
It's also negative infinity and positive infinity.
Yeah, it's unbounded below and unbounded above. So we'd say it's all real numbers, or you could go through and say from negative infinity out to positive infinity. Now, yes?
Do we need to specify the positive in front of the second?
Now, that's what I always bring up in the causes arguments. I personally always want you to include the sign on the infinity. When you're doing something and you're writing it out by hand in here, you will use a positive or a negative infinity. However, some of the assignments that you do on Math Excel, it does not require you to go through and indicate a positive in front of it. And there'll be some people who go, well, I typed in positive infinity and it said no. It will. Most people at a less than college level do not make you specify the sign. But when you go on to calculus, you'll be using a positive or a negative in front of it, so why not start now? Take a look at 3. 3 is different than what we did before. Slightly first thing up is I'm going to ask about domain. Then I'm going to ask about range. Looking at this, hands up please if you can tell me what x's give a y or what the domain is going to be. We can give it out in interval notation. We've got 0 persons. Which x's will yield a y? We've got 3 of us now. Try. thinks it's negative infinity to positive infinity. There you go. Everything works. Now, by the way, on a side note, the graphing program that we use doesn't put the arrows at the end because it allows you to extend them. So go through, make sure you give the arrows at the end of your axes. I don't want you getting a 99 because of that. The other problem, though, is now we're going to look at the range. And the range on this is just a little bit different than how you've done it so far. The range on this one's going to be different. You want to say it again?
0 to positive infinity.
That's terrific. Always put parentheses at plus or minus infinity, but when we go over here, do we put a bracket or parentheses? Well, in order to answer that question, you have to say, is 0 included in the graph? Does this graph go through 0? Absolutely. Absolutely. Now, before we do the next one, we're going to talk about whether something is a function. And something is a function if every input has only one output. So if I plug in a 3, how many outputs do I have in number 3, or a 4, or a 2? How many output values or y values will I be relating that to? Just one. You don't get more than one. Is this going to be a function? Yes. If every input has only one output, it's a function. Now, the lazy definition that they always tell you is, oh, it's a vertical line test. So we'll go over why the vertical line test works in a minute. Looking at what's there, though, this is going to be a function. Do I use every possible y value in making this graph? Is every possible y value used? Got something over here. Who can tell me what y values I'm not using when I make this graph? Negative ones. If the graph doesn't use, if it's a function, it passes the vertical line test. Every input has one output. If the function uses all of the available y values, it's called an onto function. If it doesn't, it's not an onto function. This is a function. Is it an onto function? No, because we didn't use these negative y values. Is this a function? Is it an onto function? Who can tell me? Hands up, please, and tell me why. Example 2 would be an onto function. In the range, yes. The output values go from negative infinity to positive infinity. You're going to reach all of them at some point. Now, some people over here go, this is an onto function also. And they're wrong. Hands up, please, if you can tell me. And they were sitting there trying to argue with me. I make like maybe one mistake in an entire year. And it's because I get so excited. I sometimes trip over my own videos. Who can tell me why example 4, that's not an onto function? Nope. Oh, you're right. I'm sorry. Well, I'm thinking there's another reason. I have a bigger issue with it being an onto function. I take issue with before that. Do you know why? How can it be an onto function if it's not even a regular function? You can't get to the second part of the definition. Why isn't this a function? February has multiple outputs. It doesn't work. It doesn't matter that Josh isn't used because it doesn't even reach the first part of the definition of an onto function. Now, we'll talk about after that. I think everything that we do is kind of easy. The domain is the inputs that we use. In high school math, we call them x values. You're not guaranteed that they're x's every single time. And then range is the output values that we use in going through and making the relation. You have to make sure that as you go through and list those out, the x's are what or the domain is what's plugged in, the range is what you get out. In our Cartesian plane, it just happens to be an x and a y. And it says go back to the previous examples and state that. You've already done that. It's easier to go through and deal with it all at once as opposed to view it as 4 or 5 separate topics. Questions on these? All right, let's bounce forward. We're going to state the domain and range of these. So first thing I'm going to do, I'll get rid of those. You fill those in. You state out what your domain and range is going to be in 1A. What would our domain and range be in 1A? You want to do the domain, Mike, or the range? Hey, what's your domain going to be in interval notation? Terrific. Terrific. Do I do range? Okay.
Bracket maybe to the houses
What's the difference between a bracket and regular?
If you go through, we're actually going to see in the next one, but if you don't, if the function goes through that value, if you actually encounter that number, then it gets a bracket. If it goes up to but doesn't include it, you put parentheses there. Taking a look at what's going to happen in 1B, the first thing we're going to ask you to identify is the domain. Now, everyone starts screwing this piece up because of the labeling, and I don't know what it is about it. But when I label the y-axis, you immediately think it's an x. Looking at what's there, think of it, well, there's one value, a single value that's not included in the domain in question B. What's the one value that's not included in the domain? Go ahead. So, it's going to be, normally you'd say all real numbers except for 0. In interval notation, remember it goes lower bound, upper bound, so we need to include everything except what value again? So, I'm going to go negative infinity. That means I'm way out from the left and I'm sliding in. The first time I'm going to have to go through and jump over or not include a value is at 0. So it's negative infinity to 0. Parentheses, because it goes up to but doesn't include 0. That's what the open circle in the graph means. Now I'm going to jump, and at what x value do I resume this? And some people in the other group, and I guess you're not wrong, some people go, well, the other was negative 0 in the first one, and then it's positive 0. I guess if you want to think of it that way, oops, you are approaching 0 from the negative side. Now the range is more interesting, because this is a real push as well. Look at the output values that you're given. Tell me what they think our range on this would be. Now, I know you've got the right values there, and you're thinking in terms of the y. But as I go up, what's the lowest y value that as I'm going? It doesn't go down to negative infinity, right? What's the lowest y value that is in our graph? And then it goes to. So they were arguing this, and it goes through. And the first group had this, and I'm going to don't forget down this way. They put this down. Who can see a counter or see why there would be an issue with this? Because we should be able to say, wait a minute, something about this. You're thinking about it doesn't include what? No, it does go through, like right here, the y value is -1, right here it's +1. Yeah, it's this awkwardness because we're going, this right here tells me that there's something between -1 and 1 included. Look at this graph. Is any of that used? You get 0 as a value. No. So what we have to do is, and we'll tighten it up by doing this. This and this. So we're going to tighten it up by saying one of two ways. We could either say it with the fancy brackets and say -1, 1. That's one way of doing it. Or giving it as an interval is kind of interesting because it's only -1, and then we're going to join that with a second value of 1. But it's only one number. There's not a lower bound or an upper bound. And somebody made the argument, well, can you put -1, -1 with brackets on the outside, u, than a bracket with a 1 comma 1 because it's lower than upper. And I'm not going to say you're wrong. That's viable. Yeah.
What's the difference between like the early brackets and
These right here denote distinct individual values, whereas if we were to put like parentheses here, it could be interpreted either as a point or an interval. Okay? What questions do we have on this? Because this is tough. All right, let's bounce over, please, to the next one. Now, and we'll tell you that you all are taking the same course that they are taking at Fayetteville Manlius and at Pittsburgh Sutherland. The three of us got together over the summer and made everything together. So, the lady from Fayetteville Manlius, which is just outside of Syracuse,
That's far out,
didn't
yeah.
change hers. So we're going to be Fayetteville Manlius, but we'll say it as Shader students. So look at the first one. Look at 2a. And by the way, a function, it's up there. You don't have to write that out, do you? I think I gave it to you right away. A function is a relation that every input has at most one output value. So looking at that one for 2a, Logan, what would you go through and say? Is 2a, is that a function? Why not?
Because February is used twice.
The input of February has 2 outputs. If an input has 2 outputs, it is not a function. If the input has 2 outputs, it is not a function. Take a look at B and Maddie. Maddie, is B going to be a function, yes or no? Why do you say, that didn't sound very firm in your answer. Why is it a function?
it's two inputs, one output.
No? All right, who can tell me why this would be a function? What's your justification? If I said, you tell me, what do you want to say?
There's only one output. So it's just
Every input has one output. That's it. If every input has one output, we're good. Now let's look at this. So Schrader students is the input, and the output is the guidance counselor. Think about that relationship. If the input function is you, and the output function is the guidance counselor, is that going to be a function? Spencer, what do you say? It will be. Can you tell me why? Raise your hand if you have at least one counselor in here. Guidance counselor. Anybody have 2 guidance counselors? There you go. Otherwise, we'd have to change our answer. Now let's go the other end. Now you're the guidance counselor is the input and the students are the output. Is that going to be a function? Lauren, what do you say?
no, because input has
There you go. Who knows who their guidance counselor is? in here? Who's your person? Who remembers this? What's yours? Icon? All right. So if you're Miss Icon, how many students are mapped to you? Yeah, a couple hundred. Going the other way, so you're not a function because you aren't mapped directly to one. Going the other way, though, each of you has a unique counselor. How about for E? C. Olivia C. Olivia, is this going to be a function? Why? Every input has one output. Take a look at this for 3. Now, we get into this lazy definition. I hate that these Alex 1 teachers go, oh, it's a vertical line test, that it's a function. Do you know why the vertical line test shows whether or not something is a function? No idea. And they'll tell you to go, just know it. This is the things that, I don't want you to interpret it as me ever being hard on you. The reason that the things that bother me is when they take a shortcut and don't focus on what you know instead of like how to answer a test question. The reason that we use the vertical line, that's not a vertical line, but close it. That terrible vertical line when we sketch it out, let's say that this is if x is equal to 2. How many outputs or y values does this graph have when x is equal to 2? How many? 1. That's why it's a function. Now I'm going to go over here and give out another, hopefully actual vertical line. And we're going to say this is at x is equal to -3. Hands up, please, if you can tell me how many output values this function has when the x is -3. That's why the vertical line test works. There's 2 possible ones. And you only have to find one counterexample or one input that has 2 outputs for it not to work. It's that easy. That's, again, why I get frustrated when we take a shortcut route. Take a look at what's there, please, for function notation. This is something big that we'll be working with. There's 4 ways to list out a function. The Regents mandates that you see, only 2, not all 4. A function is a rule or a way to go from an input to an output. It's a set of operations, something that gives me an input and relates it to an output. Now, this is telling me the 2 ways that you're going to see. This is called function notation. This letter in front is the name of the function. This right here is the variable input. So this is telling me the function f with an input of x would be equal to that input, or that x being cubed, then plus 3. So if I had f of a star, that would be equal to some star cubed plus 3. That's what function notation tells you. You take an input, and the reason that we have f there, it could be any letter except probably you don't want to use an x of x. The reason that you have it there is when people were writing back and forth to each other about mathematics, when math was starting to become a university subject and breakthroughs were being made, they would talk about these formulas. And you don't want to keep writing out the formula every time. So they needed to name it. They said, well, it's a function, so we're going to name it the function of x. You could name it a of x, b of x, c of x, d of x, j of x. It doesn't matter, h of x, g of x. We use all of them. This notation down here shows you what your input and your output variables are. This one doesn't mandate that you use what. You could have it be the point x comma b if you wanted to, or a. This tells you that your output is defined as a y. These 2 that are highlighted there, this is telling you that the function f has x as an input plugged into that expression. This is telling you x input into the f function is defined as follows. Any of those notations don't mean the same thing. Think of it like a machine. Here's your input value. You plug it into the function. You do your operations on it. And you get a new number, which is your output. This would be your domain value. This is your range. Questions on that? Now, I go through and look at this, and again, we're not gonna finish quick enough. G of 3. Here's one thing too to make sure that we understand. We've got the square root of the quantity x minus 3. Did we go? I think we did in here because I know I was irritated that you didn't know it. Does anybody know the name of the expression under the radical? Thought we said it in here. Maybe we didn't. There we go. It's called the radicand. We're past the point of it being sort of cute and adorable when you don't know what things are called. It's more frustrating because we want you to be successful. I'm not prepping you to go through and not have math your senior year. I'm prepping you to get a 5 on the AP exam your senior year. Maybe you'll be so smart that you take pre-calc over the summer, and then you get a 5 on your AP as a junior. And then we'll make a separate thing on the wall of fame for you. It could be a separate, a double wall of fame. Now, when we do this out, it's telling you to take g of 3. That means go to the g function and plug in a 3. When I do that, I take my input minus 3. So in this case, it's going to be 3 minus 3. Now, please understand, this is another thing, first block. It was early, so I don't think my blood pressure was too high. But literally, I said, all right, now what does the radicand go to? And I heard this. just tell me you hate me right to my face. It's less painful than hearing those buttons go. Why would I be outraged and offended simultaneously? Hopefully we know that 3 minus 3 gives you a 0. Now, this apparently, some of us think that this is a big subject of debate based on polling you. Can you evaluate out the square root of 0? We always get, it's a very split group. Hands up please if you say yes, we can evaluate out the square root of 0. Don't be shy. Oh, all right, 4 of you, 5. Who says no, you can't value out the square root of 0? See? It's like about 40% of you voted, and most of you got it wrong. The square root says what number times itself gives me the radicand. 0 times 0 gives you 0. So this would simplify out to be a 0. So our next one up, and this is another one that we're going to take issue with, and I'm going to tell you, I'm not going to finish. So what's going to happen is, again, just like I did the other day, who went through and actually watched the video from the other day? How long was it independent? Was it 5 minutes? 7-ish minutes? The problem is I need you to make sure you're at the same spot. Today, it ended up being that we got the fire drill in it. I'll reference it out to you all, the video from the other class. You need to make sure you get what they got done. Okay? I don't want you to fall behind. I don't want you not to get 100 because of one example that we didn't get to in here that another class did. I personally would be devastated if a question that we did was something you didn't get a 100 on. And it was because of something as dumb as a fire drill. So I'll message it out tonight. Scrub to the end of the video, and you'll be able to go through and see it. Now, your homework on there, before you go, this is good news, and you're going to want to stay to listen. On the homework sheet, the packet that we did before, the questions are sequential, but it says on there, worksheet 1.2 or 1.2. Does everybody have it? It says worksheet something for homework tonight on the left. Did I give you that worksheet?
No.
So do you have to do that worksheet?
No.
There you go. You're free to go, angels. Have a good rest of your day.
Am I actually getting